Hello and welcome to Spacewalk's Money Talks, where we talk about outer space business, technology, and policy. I'm Chris Alvarez, and today's guest is James Miller, who talks about planetary spacecraft navigation and about JPL history. This interview is being posted in 2 parts. This is part 1. Thank you for listening. I'm speaking with James Miller, author of Planetary Spacecraft Navigation. Thank you for speaking with me.
Thank you.
So first, tell me, so you have a long and distinguished career in space. So tell me about your career and how you ended up writing this book.
Okay, well, I started working, actually, I can go back to when I graduated from college.
Sure.
I went to work for Westinghouse Electric, and I worked on nuclear submarines. And I worked on the safety of nuclear reactors. And at that time, there was only 40 or 50 nuclear reactors in the whole country. There was one power plant, and Westinghouse essentially had a lock on all the business. Pressurized water reactors, that was an invention of Westinghouse, and they were in the submarines and the aircraft carriers and stuff like that. And I worked on the safety, and the problem it kind of evolved is that all the work was done and there wasn't anything new to do.
Oh.
And this later happened, I think, to me in the space program. But having gone through it a couple of times before, I was able to deal with it. But anyhow, I went to Carnegie Mellon in Pittsburgh, and I worked there. And then I decided that the nuclear program isn't going anywhere, and the space program was really taking off at that time. This is around 1962, 63. So I just decided to jump over onto the space program because they were desperate for engineers.
Okay.
And I wound up working at Lockheed Martin in Baltimore, and I worked on the Precision Reentry Vehicle, which is essentially the same trajectory that the shuttle uses to re-enter the atmosphere. So it was going to land at Edwards Air Force Base. But the vehicle I worked was a prototype, and it was not manned. It was unmanned, and we flew it to Kwajalein Island and dropped it into a 10-mile circle. So that was the mission it was on. And and I wanted to live in California, and I'm in Baltimore. I kind of learned to like Baltimore, but I had kind of stopped looking at the ads in the paper. I just decided I think I'll just stay here. And then I just happened to be looking through the Sunday paper, and there are usually hundreds of ads in there for engineers at the time. It was like a phone book of ads for engineers. The Los Angeles Times was just jammed with them. Maybe 10 pages of ads for engineers. And Jet Propulsion Lab had an ad. I went down and I interviewed them in a hotel room, kind of secretly. And I filled out a big, thick application. And I only had most of it was blank because I didn't have any papers that I published, and I didn't have any academic qualifications. But I knew how to analyze nuclear submarines. I was with analog computer. I was good at that. And I was learning how to program digital computers too. And this is what I did for the rest of my life, essentially. This is what got me into writing the book eventually.
Okay.
And I thought that they wouldn't be interested in me because it looked like they were interested in really smart people. So I forgot about it. And about a month later, they're very slow. JPL is very slow at doing interviews and stuff like that. I get a phone call. And they said, "Well, we'd like you to come out for an interview." I said, "What?" So I said, "Okay." So I didn't want Lockheed Martin. I was working for them at the time. I didn't want them to know what was going on. So I got the red eye at night, flew to Los Angeles, stayed in the Huntington Sheraton Hotel, which is a beautiful hotel in Pasadena. But on the flight, there was a bomb scare on the plane.
Oh, wow.
And it was the guy across the aisle from me was the one that had phoned it in. He had a uniform on, and he looked really nervous. And when the pilot said, "Evacuate the plane, we have a bomb scare," and they gave us free drink coupons, I knew he was the one that did it, and I knew he was AWOL, and he was trying to get cover for being AWOL.
Oh, wow.
So, so I got back on a plane. Needless to say, I arrived in Pasadena having the liquor was free on the airplane from then on. So I wound up pretty drunk by the time I got to my interview on the next day.
Mm-hmm.
And well, I was sober in the morning anyhow. Beautiful drive up Linda Vista Avenue.
Mm-hmm.
You're probably familiar with that. And there was snow on the mountains up above Mount Wilson up there.
Okay.
I took one look and I said, I don't care what they want me to do. I'm gonna take this job. And I got to JPL and I had a really good interview. I talked to them and they I had 5 years. I was going on 5 years of experience. They did not want to hire anybody fresh out of college. They needed people who could do things right away.
Okay. Yeah.
And I had some experience doing. I worked on the original Voyager proposal, and I did the orbit insertion there. And anyhow, I got. I went back to Baltimore after it was over. Got in early in the morning on another red eye,
mm-hmm.
and showed up for work. And I told him I was sick yesterday, and that was the end of that. And then I didn't hear from him anymore. And then I remember in November, I guess it was. This is another month later.
Mm-hmm.
There was a power failure in New York City. It was blacked out, and I'm sitting there, and the phone rang, and they offered me a job to come to JPL. And I said, okay. And they said, when can you be there? I said, in a couple of weeks. Okay. So I loaded my car up with everything I owned and put it in the trunk and took off for California. And that started my 50 years, essentially, working in the space program, 35 of it at JPL.
So the Voyager work, are you saying that was with Lockheed, or that was a project you...
Yeah.
Okay. So
there was an original Voyager proposal. It's not the Voyager that JPL did. It was to put two spacecrafts on the Apollo rocket,
mm-hmm.
the Apollo 11 rocket, put two spacecraft on one rocket and send it to Mars. And it never was done. I did the proposal. I did some work on the proposal for that.
Mm-hmm.
So that gave me a little bit of experience that was along the line. So I knew what JPL was. I learned because JPL was managing that proposal.
Okay. And looking back, do you think if they had launched it, would it have worked, knowing what you do now?
Yes, I think it would. I think it was a good idea. It was just too expensive to buy that launch vehicle.
Okay.
That's why they didn't do it. But it was a little risky because if it crashed, well, at that time, the success of interplanetary missions, half of them would crash or be unsuccessful. And so I got to JPL and I told them that, after I got done interviewing them, they said, I told them I was going to go to UCLA and get a master's degree
mm-hmm.
to finish my education because I had a little bit of graduate work at the University of Maryland and also Drexel in Philadelphia, with Planet at Lockheed Martin. And they said, well, we got a lot of people here who are going to school and getting more education. We don't need that because they don't. Essentially, they're more interested in their schoolwork than they are in actually working on our missions we got here. They said, you can forget about any more education. We just want you to start working.
Okay.
So that I like that. That really set me off because I thought, okay, I'll forget about any more education, and I learned on the job, and I had some very brilliant people that were teaching me. This was and JPL at the time had 5,000 billets.
Mm-hmm.
I was a billeted employee. The contractors were separate, but there wasn't hardly any of them at the time.
Mm-hmm.
So as a billeted employee, we had probably about enough work for 7,000 employees.
Oh, okay.
And so we had to pick and choose what we want to do to some extent.
Wow.
There was a real shortage of engineers.
Mm-hmm.
And the reason is I graduated from Carnegie Tech. It was Carnegie Mellon now. And I could get a job at any company in the whole country.
Mm-hmm.
People would just take airplane rides all over interviewing.
Mm-hmm.
And once you get a job like at a company like IBM or Westinghouse, that's a job for life.
Mm-hmm.
They don't like people that quit. And I decided, one of the things I decided early in my career is that whatever people tell you is the right thing to do the opposite, and you'll succeed in the long run. So by the time I got to JPL, I had already worked for 3 different companies, I guess. That was my 3rd company, actually. I started in the spacecraft end of it, and what I was doing was working on the division I worked in was responsible for the power of the spacecraft, the attitude control system, and the central computer and sequencer, and the scan platform, and that's about it. Which is all the guts. That's the solar panels. That was the guts of the spacecraft. And I'm an electrical engineer, so I understood. I could quickly understand how all that worked, because I worked on wiring diagrams for nuclear power plants, so I know how to wire things up.
I'm speaking with James Miller, author of Planetary Spacecraft Navigation. You can find more information on the Springer website for the book. If you like this podcast, please take a moment to rate it on whatever podcast feed you're listening to it on. These ratings go a long way in increasing the popularity of my podcast. Please sign up for my newsletter at spacewalksmoneytalks.com. Please post your comments and questions about this podcast or the episode on Facebook at Spacewalks Money Talks or on YouTube at Spacewalks Money Talks. You can contact me directly on Twitter at SpacewalksMT and on Instagram at Spacewalks Money Talks. If you like military history, please listen to my podcast, Military History Inside Out, located at warscholar.org and militaryhistorypodcast.com. If you like science fiction, fantasy, and horror, please listen to my podcast, Full Contact Nerd, also located at chrisalvarez.com and fullcontactnerd.com. Now back to the podcast.
While I was at Martin, I actually did the nuclear power plant wiring diagram for a reactor they were building. I went to Panama and all that. So I was only, I was 24 years old.
Yeah.
So I come to JPL, and I'm 25 now, and I'm an old guy now.
Yeah.
Because they don't want it. It was hard to get people with experience to quit where they were working and switch jobs. Because
right.
The culture was really against that. So JPL was really hurting to get the people. So I wound up having a job that I thought, what am I doing this for? I became the guidance and control analyst on Mariner 6 and 7. And I was responsible for 16 people analyzing the spacecraft. Of course, that was what I learned. One thing you learn about JPL is they tell you you're responsible for something, but you're really not responsible. Because if you try to make a decision to get somebody to do something, then somebody else can overrule you quite easily. And so I learned that at JPL, responsibility didn't really mean too much. They're just interested in people getting work done.
When you say analysis of the spacecraft, can you be more detailed about what that means?
Okay, well, we had the telemetry would come back from the Deep Space Network, and it was decoded from the spacecraft, and we had like in the spacecraft operations facility, we had 3 rows of disks, and all my guys were on the back row. The other 2 rows, they didn't have much to do because all the activity on a spacecraft is in the electrical things and things that move. And the rocket engine, the thrust, propulsion. The propulsion division guy is responsible for the motor, but he wasn't responsible for computing how much delta V and when to turn it on and off and things like that.
Okay.
But the analysis, let me go back a little bit.
Sure.
The data would come down, and we had like about every analyst had a teletype machine sitting in front of them. So we had 30 teletype machines, the kind that make a lot of noise like a newsroom. And when we launched the spacecraft, as I remember, you're sitting there and there's no data coming, and the spacecraft is sitting on the launch pad, and it's up on the rocket. It's on an Atlas rocket, and we're sitting there waiting, and I'm looking at and we're getting data back from the spacecraft, and I could see the gyros were really noisy, and so I talked to my chief assistant, who was really a very responsible He's the guy that designed the Deep Space Network control system for the antennas. Don Acorn. He was over me, but on the team I was officially the head of that thing.
Okay.
And I was wondering what the heck's going on. He said, "Oh, it's windy at the Cape. The wind is blowing and the gyros are registering it." But anyhow, these teletype machines would type the data, the temperature, the pressure, all the gyros, and our job was to read that data. We had computer programs that we never trusted, that never hardly ever worked, that would convert the data numbers that would come down into engineering units.
Mm-hmm.
Well, after we could just look at the data number. 54 was 0 was minus something, and 128 was plus something.
Mm-hmm.
So we knew what a number was. We knew what the temperature was. Like we knew that Canopus, when we locked on the star Canopus, that had a DN of 8. That means it's really bright, because 54 is 0. So, minus 8 is very bright. Mm-hmm. It's a negative number, but and so anyhow, we would analyze all that telemetry coming in and look to see if there's something wrong with the spacecraft.
Mm-hmm. And
you have to understand what the spacecraft is doing.
Would you say that the way that's done now, obviously the technology has gotten better, as far as reading and transmission of data and all that, but would you say essentially functions are the same, that it's kind of managed the same way?
Yeah, essentially. You could. I don't know for certain, because I only worked on the hardware end of it for about 3 years, and then I switched over to trajectory and the navigation section, which doesn't get involved with the hardware anymore.
Okay.
But on that spacecraft, Mariner 6, the reason I got into this is because they had it was the first spacecraft that goes beyond the orbit of the moon that had a computer on board.
Huh. Okay.
So the problem was, how do you command the computer? So I was responsible for having a bunch of programmers program a program which I called command generation, ComGen,
mm-hmm.
and it would control the computer. So I could upload the whole entire memory and download the memory and look at it and see if it's the right bits and ones and zeros are in there.
Mm-hmm.
And I designed it like an assembler and a compiler to program the computer.
Mm-hmm.
It only had 128 word memory.
Oh, okay. So I guess, does that mean you could push out old commands and insert, new replacement commands for some new function that you needed the spacecraft to carry out?
Yeah. So I had pretty good solid spacecraft experience.
Mm-hmm.
That's the reason I'm telling you all this.
Okay.
And then I of course I got into some arguments a lot because I thought everybody was stupid. Big mistake.
Mm.
Big mistake. They're just quiet.
Yeah.
The average guy at that time, people were afraid to say anything, because if you said something and it was wrong, you could get fired. I mean, it was people really were scared, because we had, if Mariner 6 and 7 was successful, they kept saying this would be the first time ever that 2 spacecraft were both successful. Usually, if you're lucky, you get one of them to work.
Mm-hmm.
Surveyor had 7 spacecraft, and I think maybe 5 of them worked.
Okay.
But this would be the first time, and so people were very nervous. But I knew what I was doing, because I had really studied. I had worked on nuclear submarines, and I knew more about how a submarine worked than any ship captain than even I think Jimmy Carter was on a nuclear submarine.
Oh yeah.
He was a little bit before me.
Mm-hmm.
I know more about nuclear submarines than any of those Navy guys. Let me put it that way.
Okay.
And so I learned a lot about spacecraft, and I know how to take a spacecraft and look at a wiring diagram and figure out what it's doing, and then write a computer program to make sure it's doing what I think it's doing.
Mm-hmm.
So I had the attitude control, the power, and all that under me,
mm-hmm.
in addition to the computer. And of course, I had some very smart guys working for me, and they all thought they were smarter than me. So I don't really care. That was true throughout my entire existence at JPL. I don't think everybody thought they were equal to me.
Mm-hmm.
And it's only since I wrote the book that I decided, all right, I'm tired of this. We're all equal. I said, if you haven't written a book, you're not equal to me. From now on, I'm not acknowledging you being equal to me anymore.
Yeah. Let's see your book.
Well, we were all, when you work in the military, I also, before I got, anyhow, I got in trouble, and essentially I got sort of fired, and then somebody else wanted to rehire me because I was arguing with the guy who later became the deputy director of the laboratory.
Oh, okay.
But he was a strong guy. He's on the Sierra Madre search and rescue team. He was a real tough, but I liked him a lot, and we got along good. But I'd argue with him a lot too, and somehow my section manager found out that I was arguing with this very important person. Mm-hmm. So he told me not to argue with him anymore. And then I forgot one day, and I got into another argument with him. And so they said, okay, you're off the team. Mm-hmm. And then they decided that was a mistake. And I wound up quitting and going to Logicon. I worked on the Minuteman program, on Minuteman missiles. Mm-hmm. And what I was doing there was verifying that their software was correct, mm-hmm. that targeted the missiles. Okay. And I was doing pretty well there too. And if I'd stayed there, when I went to work, there was 100 employees. And I think 10 years later, they sold the company to Northrop Grumman for $750 million. Mm-hmm. And it was like 4,000 employees.
Uh-huh. Oh wow.
And I had been there when there was 100, and I knew everybody in the company. Mm-hmm. And I decided that I knew that it was an opportunity because I could see the growth. But I thought that they were going to send me to Washington or Vandenberg to work, and if I want to advance it. And I didn't want to leave California under any circumstances. I said, look, I'm going back to JPL. And I decided that I don't care about getting rich. Mm-hmm. It turns out I got rich anyway at JPL, but not rich as I would have if I had stayed at Logicon. I think I'd be a multi-millionaire right now if I had stayed there. Anyhow, I called up the guys that I knew at JPL, and I said I'd like to come back. Well, this is right after Apollo had landed, mm-hmm. and there was a big layoff, and so you couldn't find a job. The newspapers, there's no ads for jobs in the newspapers, and since they knew me, even though I'm a troublemaker, mm-hmm. they'd rather have somebody that they knew could do the job than having Albert Einstein come and they'd have to train him.
Right.
Because you couldn't train Albert Einstein because he wouldn't listen to you. But they knew that I could do it and that I would listen. Mm-hmm. Knowing how to do a job if you could convince an employer that you know how to do the job really well, they're going to hire you.
Yeah. Yeah.
But I knew how to do it because they knew me. So I went back and I got into the navigation section. Now I can start the beginning of the book.
Yeah.
I just gave you the background a little bit.
Yeah, no, that's good. That's good.
So I started doing analysis now, and this analysis consisted essentially of figuring out how to navigate the spacecraft in different situations. Mm. The first one I worked on was Viking. So the Viking mission, we had 2 spacecraft, each of them on an Atlas Centaur, and we launched in 1975, and we arrived in 1976. Mm-hmm. And we were supposed to land the thing on the 200th birthday of the United States. And I kept telling the management there, I said, look, you guys, you morons are not going to land this on the birthday of the United States because nobody believes it's going to work. And what you have to do is crash a spacecraft on Mars on the birthday of the United States. NASA's not going to do it. They're going to delay it. Mm-hmm. But we had all planned, these missions, mission A and mission B. And I'd been doing analysis. But basically, my job was figuring out how to do the orbit insertion burn. Okay. It's a 40-minute burn of the rocket to get the spacecraft into orbit around Mars, mm-hmm. and compute how much fuel it would take to navigate the mission, and that's a statistical thing. So we had to guarantee that we have a 99% probability of not running out of fuel. Mm-hmm. So when you build a skyscraper or a bridge, you usually have a factor of 5 for your safety. Mm-hmm. We don't have that. We computed the statistics, but everybody padded it a little bit, but I didn't. I computed exactly what I thought the statistics really were. And then I said, to be sure, we got to make sure that, we got a little more margin than what I'm computing here.
Mm-hmm.
But essentially, that was a large part of my job for most of the missions I worked on was making sure that there was going to be enough fuel and we're not going to run out of fuel,
mm-hmm.
which we almost did on one of the missions I was working on.
Oh, wow.
That was only because of a failure. But so I worked on that, and we landed 2 spacecraft on Mars, and I developed a mathematical technique for optimizing the orbit insertion burn, and I invented some fundamental new mathematics essentially.
Okay.
Because I don't know if you're familiar. Are you familiar with engineering mathematics and stuff like that?
Not really. No, just in a very vague sense,
There's something in for optimization, something known as Lagrange multipliers.
Okay.
Louis Lagrange, and that's a way of optimizing, constrained optimization. It has wide application all over the place. And I looked at that and I said, that's not good for a computer. So there's another technique which is called gradient projection. And I was sitting there one day and I thought, I don't like this Lagrange multiplier approach. I'm going to try to do something else. And essentially I invented gradient projection.
Okay.
And people kept telling me, you really invented something that's new, and I wouldn't believe them, because my belief was, what I've been taught is that if you're an engineer, you can't believe it. You can't invent anything new, because anything you invent has already been thought of.
Mm-hmm.
So I wouldn't publish it. I just said, hell with it, but I wanted to get it into the flight software because I wanted JPL to recognize that I had done it.
Mm-hmm.
So I managed to play it cool, and I got that done. And then later on, I didn't even call it gradient projection. They decided desperately that they needed this kind of software to design the trajectory to go to Jupiter for Galileo.
Mm-hmm.
And they spent 3 years repeating what I had done in 5 years.
Mm-hmm.
But by that time, I had enough of the trajectory design. I knew how to do it, and I designed a trajectory that I later got a medal for. From the AIAA, a trajectory that goes to the moon. It was a Japanese mission.
Mm-hmm.
It's in my book, a whole chapter on that.
Okay.
That the Japanese mission failed, and so they had a spacecraft stuck in orbit around the Earth. They didn't know what to do with it,
mm-hmm.
and they only had 25 meters per second velocity change that they could do. They were out of fuel essentially. So they had all ideas of what they could do. One was just to try to do some drag experiments, dip it into the atmosphere and see what. And they really wanted to go to the moon. Well, it looked like it's impossible to go to the moon.
Mm-hmm.
So I figured a trajectory where you lop it out about 1 million kilometers away. You go fly by the moon and go out about 1 million kilometers from the Earth,
mm-hmm. 1.5 million
exactly, and you sit out there for 3 months, and the sun then takes enough energy out of the orbit that you can come back and be captured by the moon.
Oh, wow.
So essentially, I could get to the moon for nothing.
Mm-hmm.
A few meters per second.
Wow.
And this became, and they did it. The Japanese were so happy, Of course, there was a lot of politics there, but anyhow, I did that.
Mm-hmm.
And with another guy, and he did the theory, and I did the actual trajectory. When I did the trajectory, I never paid any attention to his theory, but I told him, okay, we'll both write the papers. and I'll write a paper on the trajectory, you write a paper on the theory,
mm-hmm.
and I wrote, and then we'll publish it, and make sure we get credit for this because this is important, and all that. And what happened was his theory was kind of not that good, but the trajectory was the trajectory,
mm-hmm.
and so
it worked.
So he didn't like the idea that we split it like that. He wanted to say that he did the trajectory. He had his theory, I guess, was all right. So anyhow, we became enemies for 25 years.
Yeah. Wow.
And he went off and claimed he quit JPL. Well, he wasn't actually. He didn't quit. He was fired from JPL.
Yeah.
So they didn't know what to do with him, essentially. And he went off, and so we fought with each other for 25 years. I didn't care that much I just wanted him to give me my 49% or 51%. I thought I should have 51, but I would settle for 40 even. But he kind of wrote me out of everything.
Oh wow!
And I thought, but I eventually the outside world kind of figured out what had happened, because his theory just wasn't explaining it. And then all kinds of people came up with theories for to explain this motion, and Purdue and the University of Barcelona in Spain, and they knew that the guy that I work with, that he had worked with him, and they knew that he didn't really have the right theory, and they backed me up, the guys over in Spain.
Oh, okay.
And so I didn't learn this until years later, but anyhow.
I'm speaking with James Miller, author of Planetary Spacecraft Navigation. You can find more information on the Springer website for the book. If you like this podcast, please take a moment to rate it on whatever podcast feed you're listening to it on. These ratings go a long way in increasing the popularity of my podcast. Please sign up for my newsletter at spacewalksmoneytalks.com. Please post your comments and questions about this podcast or the episode on Facebook at Spacewalks Money Talks or on YouTube at Spacewalks Money Talks. You can contact me directly on Twitter at SpacewalksMT and on Instagram at SpacewalksMoneyTalks. If you like military history, please listen to my podcast, Military History Inside Out, located at warscholar.org and militaryhistorypodcast.com. If you like science fiction, fantasy, and horror, please listen to my podcast, Full Contact Nerd, also located at chrisalvarez.com and fullcontactnerd.com. Now back to the podcast.
I was working with the University of Barcelona, the mathematics department, and Carlos Simon, I think was his name. He's the #1 mathematician in all of Spain.
Oh, wow. Okay.
And the guy that I was working with was Moser's student. Moser is one of the top mathematicians in the United States, Brown University. There's 3 or 4 really big mathematicians. Nobody ever knows them, but they're there. And so I'm dealing with all these high-powered mathematics because they're coming up with all these theories to explain my trajectory. They get mad when I say that. So anyhow, I had Ed and I, we made up finally about 5 years ago.
Oh, okay.
And the reason we made up is, my policy always has been, you fight. It's like the mating ritual of animals. Like elk, you bang your heads together in your racks, but you never try to kill your opponent. They never try to kill them. Only human beings try to kill their opponents. Kill other human beings. Most animals are pretty smart, and they realized a long time ago that sex is a wonderful thing, but it's not worth getting killed over. So I had the same attitude toward everything I do. That it's not worth killing anybody over. So anyhow. They decided to make a documentary movie about this guy's life. So this is one of the interviews that I had because I got a telephone call and they wanted to interview me.
Right, get your
I had
angle.
A telephone call, and I said they were in a car and they were almost to the Arizona border when I finally got a hold of them, because I was away and I came home and I said, oh, there's a telephone call. I called, and they're in their car and they're driving to Arizona, and they said they had wanted to interview me, and I said, oh, I said, well, it's fine. They said, well, can we interview you? And I said, yeah, sure, anytime you want, just come on in, and I said. And I asked them where they were, and they told me. They said, well, when can you do it? And I said, how about tomorrow morning? Or they said that. And I said, okay. So they turned their car around, and they came back. And the reason they wanted to interview me, because they knew about this controversy between Ed and me.
Okay.
So they wanted to make sure they got the other side of the story.
Right.
They're spending some money on this. And you know who Neil deGrasse Tyson is?
Oh, yeah.
Okay, well, he was in the movie, so I met him as part of this. We were all the three of us were in the movie. I have a picture of Ed, and so I decided when I talked to them, I said, okay, here's the deal. I said, if you got to have a bad guy, make it me. But don't take anything that I said negative about Ed, because I don't want to be in it. I don't want to, it's his movie.
Right.
So I told Ed, I got in contact with Ed. We're talking to each other, and we made up immediately. We made up so that for the sake of the movie, essentially.
Okay.
I said, look, we can't be fighting with each other. And so we made up, but he invites me back to his house, his girlfriend's house, actually back in Princeton. This is all done at Princeton. He was teaching at Princeton. And I said, okay, I'll come back. I went back there for the movie, and we had a showing of the movie at the theater right across from the university in the town in Princeton. So Neil deGrasse Tyson came down, and another guy who was a black guy who was a multi-millionaire, and we had a little afternoon party, talking for about 2 or 3 hours, and then we were going to walk over to the movie or have dinner and then walk away, and so we finally show up at the theater, and I look and I see there's a line of about 100 people lined up. And I thought, oh my, it looks like they might even be able to fill the theater. A long line in front of the theater is not very many people.
Right.
100 people. The theater could hold about 100, 200 or something like that.
Okay.
So then we walk up and we discover that these people were lined up because they can't get in. The theater is already filled up.
Oh, wow.
And we didn't have a ticket. So we had to scrounge around to get tickets.
That's funny.
And I went in, and I told the producer, I told him they did a nice job on me because I was very cooperative with them. I told them they could do anything they want. I said, look, I'm retired. I'm at home. I got all the money I'm ever going to make for the rest of my life. I'm sitting here enjoying life. There's nothing you could do to me. So go ahead and do whatever you want. and they liked that.
Yeah.
And so we watched the movie, and I saw myself on the big screen. That's I told them I wanted to sit in the back because they said that they were laughing at my jokes.
Okay.
And I said, are they laughing with me or at me? I wanted to determine that to see if if they were laughing at the right things. It turns out that they were. And after the movie the presentation was over, they said we're going to have a presentation that the members of the cast are here, and they're going to call it, and the audience can ask questions. So they called up Ed, and he comes up and walks up and stands up on the stage. And they call up Neil deGrasse Tyson. I guess he gets up and walks up on the stage. And they call me, and I'm in the back of the office. What? So I go walk up, and I'm standing up there on the stage. And then they called up the guy that was from Princeton. He's a relativity expert. His expertise in relativity is time travel.
Okay.
And he somebody asked the question, asked him about the Big Bang, about how it worked and all that. And I'm listening to him. He's standing right beside me. Anyhow, I guess I'm getting off track, but I forget where I was. But anyhow, I did that. And now I'm going to go back to Viking, I guess.
Well, let me ask.
I'm getting close to the book now.
Let me ask you one quick question. I'd like to get to Viking, but computer coding, is the coding pretty similar now to what it was back then? It seems to me that once you establish certain sort of equations or I'm not sure the right word, but what would have changed from then to now, or is it pretty similar?
Yeah, one of the things that I had people say that all that mathematics has all been invented, so there's really nothing for you to do in terms of mathematics, but that's not true. The real problem, and the reason I was able to do a lot of things that I've done is because I learned how to program an analog computer back in 61, 62, 63, and I could put a whole nuclear power plant on an analog computer and analyze the startup accidents and all the stuff that happens. Things. If I had continued doing that work, I think I could have figured out that and called up the Russians and told them that they shouldn't do what they did to cause Chernobyl to blow up. But I was doing that kind of analysis, and so. When I switched over to the Martin company, I knew you have a thing on an analog computer called an integrator. It integrates differential equations.
Okay.
And it's the key to the nuclear power plant thing is thermodynamics, and it's really so you have to solve these simultaneous differential equations, and you have an integrator. And I thought if I could get a digital computer to integrate, I knew a little bit about programming because I'd done it, when I was in school.
Mm-hmm.
Very little. Computers were something really new. When I was in school, it was only 4 years that the first computer had been on the market. So it was all that was new and very expensive.
Mm-hmm.
So I decided, I figured out a 10-line program that would integrate. I said, well, now I can do on space all the kind of things that I was doing on the analog computer, only now I can do it on a digital computer.
Mm-hmm.
So I started doing that. Little did I realize that I leapfrogged ahead of a lot of people by doing that, by not working on computers when they were so expensive and primitive, and by doing and having access to analog computers. I learned a lot of computing skills that the rest of the world had to catch up because I kind of leapfrogged ahead. And so I didn't quite realize that at the time, but I started concentrating on programming, writing programs on a digital computer.
Mm-hmm.
However, there were other programs that were already written that I would run at Martin. I didn't write my own software to analyze the prime mission, but I ran programs and I wrote auxiliary programs that to do statistical analysis and stuff like that. And so I was getting ahead of the curve on computer programming. And then I did that little work on the Mariner 6 with the computer. So that kind of kept me going. And then when I got to working on Viking, I really got involved in writing. And what I discovered is that all the mathematics that existed prior to the computer age was good for solving problems analytically on a piece of paper.
Okay.
That's what Einstein would do. He'd sit there, writing on a piece of paper. If you had a computer, you could bypass a lot of the mathematics and do it numerically, and you can get the same result numerically. However, scientists looked down upon that because they thought it was brute force, and when you analyze a problem on a computer, you don't really understand it. You understand it if you really do the mathematics. So most of the people that I work with, they bought into that BS, and what it really was, it was total BS, because it turns out that the people who do things analytically, they don't understand what they're doing. They understand the mathematics, but they don't understand the physics.
Okay.
They write the equations down, and then they do a lot of mathematics, but that doesn't help them understand the physics. But if you can run it on a computer, you can look at the numbers. You can see everything on a computer.
Right.
So I could learn a lot faster and do a lot more on a computer. So I was kind of led the effort to convert the mathematics done by Einstein and the famous mathematicians in the 1800s and all their analytical theories. I was putting all of that on a computer so that it's a lot easier to do things. And so that's what I did for my entire career. So I kind of stayed ahead of the competition by 4 or 5 years. Of course, now I'm behind because I'm retired for 10 years. But that for a while I walked away from computers for maybe 3 or 4 years because they're supposed to. If you don't go on do computers, you go into management. So I was assistant flight team navigation team chief on Viking. We had like 80 people on that team. And I didn't want to do that. I didn't want to be a manager because I realized that if you're in management, you don't do technical work.
Right.
And if you do, you don't have time for it.
Right.
So, but yet the managers who had done technical work, once they become managers, they think they know everything, and their mind is closed to learning anything new because they can't learn anything new because they don't have time to do the technical work. So after 5 or 10 years, all your managers are useless when it comes to making engineering decisions. So they have to get people working for them, but they can't admit that they don't know anything. So I just decided that I'll just go off on my own and do whatever I want. And if they don't like it, they can fire me. And my argument was that if you tried to fire me once, I said, it's not going to look good if you try to fire me again for the same thing. but so I developed an attitude of pursuing navigation independent of JPL, because all of the JPL navigators were really navigator operators. It's navigation operations. Mm-hmm. And operations is not navigation, the way I look at it.
Ah, okay.
Like, for example, you have a GPS in your car, right?
Mm-hmm.
So when you jump in the car and you want to go to the supermarket, you type in the supermarket name and push a button, and then it tells you how to get there, right?
Right.
And you follow the map. Mm-hmm. It's on the console.
Right.
Okay. So you're navigating. But in my mind, you're not navigating.
Right.
The computer is navigating.
Right.
So the computer programs that I wrote I had the computer program written that essentially could do navigation autonomously. I didn't need any people. I could just write a computer program. We'll do it all. Well, that's not going to sit very well when you have 150 people in a section working on navigation.
Right.
And their job depends upon making computer runs. Mm-hmm. But I could write a computer program that would replace them all, essentially. Yeah. Well, I knew that no one's going to be in favor of that. I continued to develop the program anyway, mm-hmm. without, on my own. And so I decided that instead of trying to argue with these guys at JPL, when they want me to do something, they'll come to me, and they did, a number of times, and they'll say, we got a new mission, like the Comet Rendezvous. We want to orbit a comet, mm-hmm. and land, or not land on it, but orbit it. Mm-hmm. And there's gases coming up. So I did all the analysis of that mission, and then they canceled it, which I knew they were going to do anyway. Yeah. So I decided that the best thing for me to do is to write papers. Okay. Mm-hmm. So paper, and present them at the AIAA meetings. And so that was good to do. So I'd write a paper like every 6 months. Mm-hmm. Whatever I did for the last 6 months usually, or maybe a year, mm-hmm. I'd write a paper. It'd be about 20 pages, 10 to 20 pages. Mm-hmm. And I thought, I ought to write a book. Well, I decided that about 25 years ago. Uh-huh. And one of my friends, he said, Miller, if you write that book, there's nobody in this section that's going to read it, because essentially they don't like you. I said, I think you're right. And I wrote about 30 pages, and I realized, oh my God, if you get a book has to be thick, 200 pages minimum. Oh yeah. But I 350. If you write I read a lot of mystery novels. They're all 350 pages.
Yeah. Yeah.
So those are your books. That's a book. Sitting down and writing a technical book with equations in it, mostly 350 pages, it would take me 5-10 years. Mm. I realized that, Yeah. So I decided I'm not going to do that. I mean, I'm getting into talking about the book now.
No, that's fine.
That's what you're interested in, I think.
Well, both, but all of it. Okay.
So anyhow, so I'm writing papers, and I'm having a good time. I write a paper, I make them real, and early in the stage, JPL had the best graphics department, better than public publishers of books nowadays. They had a graphics department that was really first class. They turned out beautiful reports, beautiful figures and everything on them. Mm-hmm. And whereas other aerospace companies, it was like what you could do with a Xerox machine. Uh-huh. In fact, a lot of the earlier work that I did was mimeographed. The blue mimeograph paper. Mm-hmm. But at JPL, you could do some really nice-looking papers. So one of the things I learned when I was at JPL is never think of yourself as superior to the people who are on the doing the work. Mm-hmm. The people who do the key punch operators, the photographer. They had a photography department, unbelievable. And so I knew how to make friends with these people, because mm-hmm. I come from Pittsburgh. I come from a working class neighborhood. Mm-hmm. And so I kind of knew how to. I even though I didn't get along with most people that I work with, because I didn't want to. If I wanted to, I did know how to. So I was able to get my papers done really, really well, and I got a lot of support. And when we landed, when we were going to land on Viking, about 3 months before we were going to land the spacecraft on Viking, mm-hmm. we decided we needed a navigation plan supplement. We had a navigation plan, which was it was 50 or 60 pages or something like that,
Mm-hmm.
maybe 100. And so the nav team chief, who was Bill O'Neill, he's the Galileo project manager. I don't know if you know who he is or not, but anyhow, Bill, he was my supervisor. So he said, well, why don't you put together a navigation supplement? So I said, okay. So essentially, as the editor,
Right.
I put together a 600-page flight plan for landing the spacecraft on Mars.
Wow.
I only wrote one little chapter for it. I went around and I got 10 different people to write 10 chapters.
Ah.
And I went around and I got them to do, and then I read it and edited it. If they were good writers, most of these guys are excellent writers.
Mm-hmm.
They can write better than me any day. But half of them weren't so good writers. So I would rewrite whatever. If it wasn't good, I'd rewrite it to get it to be a little better.
Mm-hmm.
And I think I was the only one at JPL that could read the whole thing and understand it. Because all of the stuff that had to do with the landing on Mars, with the accelerometers and the gyros and all the stuff, that JPL doesn't do that. There isn't anybody that knows how to do that. But I knew how to do it come working on Minuteman. I know how the Minuteman missiles are going. So I understood navigation on a much broader level than you find at JPL.
Mm-hmm.
So essentially, I edited the nav plan.
One question I have is, you know that when they had the two first stages recently, SpaceX landed the two first stages, reusable. They landed simultaneously or just about.
Yeah.
Do you have any comments on that? Like when you saw that, I'm just curious.
Well, my comment, first of all, I think that landing the launch vehicle,
mm-hmm.
like they do, that was originally done by Douglas back 30, 40 years ago.
Mm-hmm.
And then they decided it wasn't a good idea, and they just abandoned it. So my comment upon Musk is that SpaceX doesn't do anything original.
Mm-hmm.
In fact, one guy I remember presented a paper at a conference, and he was comparing the technology of different things, mechanical things that are around, like a VCR, and stuff like that, and a washing machine and an automobile and all that stuff.
Mm-hmm.
And he came to the conclusion that a rocket has about the same technical level as a washing machine.
Mm.
There isn't much more to it than a pump that pumps some stuff. It was a big deal. Of course, this guy wasn't around when I was around. There was a big deal about pumping hydrogen for the Apollo mission. They put out a notice that they were trying to develop pumping hydrogen into the engine. And it was a big deal.
Mm-hmm.
They finally got it to work. But anyhow, there isn't that much to a rocket. So the SpaceX guys have taken a lot of the technology that was developed by the aerospace industry,
mm-hmm.
and just they built these rockets, and they claim that this is the first time a private rocket firm has done anything.
Mm-hmm.
Well, the problem with that is that, first of all of this military stuff that's done in the United States is done by private companies,
mm-hmm.
but they're done under government contract,
mm-hmm.
and essentially the people who work in the aerospace business, they can't even balance their checkbook, let alone manage billion-dollar contracts.
Mm-hmm.
So they dish the money out, and these guys do the work, and then somehow the money is usually disconnected from the work. But if you look at the bottom line, is that if I'm working on a space project, let's say it's $100 million space project.
Mm-hmm.
The amount of money that goes to the steel and the materials and the computers and all that kind of stuff is small compared. Most of that money goes to salaries for people working on the project.
Okay.
So now you have $100 million, and that pays the salaries of X people. Okay.
Right.
Well, they're going to save money. So now so for $95 million, they give a contract to SpaceX. So SpaceX takes 15% off the top. Okay. So now you're talking about $80 million in salaries.
Mm-hmm.
Okay. So now their argument is that private industry are a lot smarter, and they know how to do things efficiently, and they know how to. They have all this know-how, and that's complete nonsense because they don't.
Mm-hmm.
So my feeling is that I would not want to get on that rocket. That's my feeling. I wouldn't trust them.
Interesting.
Build it.
Huh. That's very
like a Tesla. I wouldn't want a Tesla either.
Yeah.
But I like Elon Musk because I like guys like him. Mm-hmm. He's like, I identify with him. He's a renegade.
Mm-hmm. Yeah.
So if he's successful, good. That's great. More power to him. Mm-hmm. But I'm on the government side of spending money, and the way my reason for wanting to work on Minuteman missiles and big expensive spacecraft. I never worked on a spacecraft that in today's dollars would be like $400 million spacecraft, but I've worked on $1 billion spacecraft. And that means if you run the $1 billion spacecraft into a telephone pole, that's the end of it. Oh. And that's $1 billion right there. You lost.
Yeah.
And so the people who work in this are not dedicated to making money. The engineers, they don't even know. They don't know much about finance. And the only reason I do is because I have a friend who kind of educated me. Mm-hmm. He's a real financial whiz, so to speak. He's probably worth $5 or $6 million. I guess that's a lot of money. I don't think of it that much anymore. but he, I learned a little bit about finance from him. But people at JPL, they like to do they're dedicated to their work.
Mm-hmm. Yeah.
And if you put together $100 million worth of these people, you're not going to be able to beat that. Private industry can't beat that. I don't care how efficient they are. That's what I think.
Okay. What would you tell someone who's maybe new to the kind of work, who now is doing the kind of work you did, maybe new to it just out of college or maybe a few years in? Is there any kind of education that you'd like to see them get to make them better that they're not getting? I don't know if that's anything you ever thought about before, but I'm just curious.
Well, that's essentially the reason I wrote the book that I wrote. Because I kind of figured that the emphasis in the academia and the colleges is on the analytical approach, and they shun computers. Mm-hmm. But recently, in the last 15 or 20 years, they've become more and more people that get an engineering degree. They know how to program a computer, so they're getting a lot better at it. But the culture of the older guys is still that computer results are not as good as analytical results. Mm-hmm. And I fought that battle all my life, and so one of the things that I think once a guy comes, I would like to see universities spend more attention educating people to do things the way I do it, doing computer work, and they do a little bit more than they used to, but still the professors they're advising them for their PhD, they don't know how to program a computer very well, and it's hard to manage somebody programming a computer. You just kind of look at the results they get, and then they write their thesis based on that. I see. But I'm definitely on the side of computers, and I'm not. Like, for example, at the last conference I went to, there was a guy there, and he presented a paper on the three-body equations. Mm-hmm. By the way, that trajectory that I discovered, that was the world's first solution to the four-body problem.
Okay.
Where four bodies simultaneously attract, or three bodies simultaneously attract a fourth body. Right. It's a restricted four-body equation. But anyhow, he came up with an analytic way of doing the three-body problem, and he's at JPL. I know him, and he's presenting it. And he makes the point a couple of times that he doesn't have anything at all to do with computers. And so I went up to talk to him after it was over with you. I try to let him know that if you work at JPL and you don't have anything to do with computers, you're not of any use to JPL. Your three-body stuff is just worthless. And he kept talking down to me in terms of mathematics. This is a total derivative, and use mathematics like I don't understand it. But anyhow, my thought was that there are a lot of people in academia that love what he's doing.
Mm-hmm.
But he's a JPL. He should be doing computer work.
Mm-hmm.
And he should be proud of the fact that he's not doing computer work.
Hmm.
But anyhow, that's kind of the if I had to give an advertisement for my book,
mm-hmm.
what I'm trying to do is I'm trying to show everybody who reads it that I understand the mathematics.
Mm-hmm.
And I'm not doing this because I'm too dumb to understand the math. And here are the computer results that you get. This is the way you do it on the computer.
Mm-hmm.
And then you can calculate the numbers with your formula, and you can look at my computer results. You can see they're exactly the same. So that means that I got the right answer a lot easier than you ever did.
Hmm.
And most of the problems that you have, you can't solve them analytically. You have to do them on a computer.
End of part 1. Thank you for listening. You can find more podcasts like this on your favorite podcast feed under the title Spacewalks Money Talks. That includes Apple Podcasts, Stitcher, and Spotify. One great way to support me is to rate my podcasts, either good or bad. You can find more fascinating information at spacewalksmoneytalks.com, on YouTube under Spacewalks Money Talks, on Facebook under Spacewalks Money Talks, on Instagram under Spacewalks Money Talks, and on Twitter at SpacewalksMT. Don't forget to sign up for my weekly newsletter where I recommend newly published books. The subscription box is on my webpage. Thank you for listening.